It's Pico-8 day once again. My name's Dave. Let's play with Pico-8. This is pico-8-edu.com. Start it up. All right. Today we're going to talk about maps. It's going to be fun. We got to get something out of the way first. We've talked a lot about variables. We've been like x equals 10, whatever. What's x? It's 10. A number is a type of variable. Another type of variable that we have dealt with is a function. We can say, what's the type of an int? It's a function. What's the type of x? It's a number. We have made tables. You could say like table equals 10, 20, 30. The type of our table variable is a table. We've dealt with like a true or false. When we write something like 1 is less than 2, returns true. So if we do like obvious equals 1 is less than 2, the type of obvious is a Boolean. It's another type of variable that is just true or false. There's another type of variable that we'll use a lot. You put it in between quotation marks, and it's basically text. And the type of that text is called a string. Types are kind of like files, like file types on your computer. It's all data, but the way a text file is encoded is different from like an MP3 or like a GIF. And so trying to open one with the wrong program, it just like doesn't make sense, or like adding them together doesn't make sense. So I can't be like, you know, if x equals 10 and name equals Jerry, if I say what is x plus name, it makes no sense. Just like if I try to do name plus table, it makes no sense. I can add that name to the table. And then I can do for v for value in all table, do print v, and we see the list of things in that table. And they're mixed types. So there's 3 numbers and Jerry. So strings are helpful for a lot of things. Usually it's for like printing things to the screen. If you have dialogue or just like UI that says something like HP or whatever. Useful. So that's an intro to types. I want to show you something about tables. Now this for v in all table do print v. We have a table and it's got 4 things in it and they're in order. And we've seen this before with like bullets. We've seen it with stars, where we fill a table with things and we loop through it and do things with everything in that table. We pull things out of the table. We haven't really explored how that's organized. So a table can have like x equals 10, y equals 10, right? But then things can also just be in order. And we call that an array, usually, in most programming languages. But an array and a table, array is kind of mixed into a table in Lua. So I can say, let's make a table of animals. Cat, dog, mouse. All right. If we want to ask how many things are in that table, use the pound symbol the what is it called? The hashtag. Isn't it like the Octothorpe? Hold on. I gotta look this up. Yeah. It's called the Octothorpe also, apparently. It's got like 100 names. TBL, that will tell you the length of the table, which is like really handy a lot of the time. If you want to access a specific numbered variable inside your array style table, the way you access it is table, and then not the curly brackets, the straight brackets, and then a number. So 1 is cat, 2 is dog, 3 is mouse. And we can add to our table bird. Now bird is in 4. The length of our table is 4. There's one more type I want to talk to you about. What if we try and ask the computer about a value in a table in our table that we know doesn't exist? We get nil. Nil is Lua's way of saying there's nothing here. It's not even 0. Like 0 is a number. 0 has meaning. This is nothing. But the weird thing is about Lua, we can say table 500 equals Jerry. And now there's something at position 500. But if we ask the length of table, it says 4. If we say table 0 is equal to scorpion, we ask the length of table, it still thinks it's 4. But it knows, if we ask it specifically, well, what about 0? It knows there's more data there. The way Lua thinks about table length is it looks at position 1, and then it starts counting up until it hits one where there's a nil, and then it says, all right, that's how many things are in that table. So if there's like a space and then more, it doesn't know about it. And if there's anything before 1, it doesn't really know about it. Now, this can cause headaches if you don't know about it, but you know about it now, so that's cool. You can also kind of get away with crimes because of it, and we might do that today. And I want you to be prepared. So usually we write our for loop like for v in all table do print v. But you can do for I equals, and start at any number. Usually we've been starting 1, but you can start at 0 because we know we put something at 0. Comma, do the length of the table, or what it thinks the length is. Do print table I, end. So we are starting our I at 0. It's going to loop until it's the length of the table. And it's going to access that I position in our table and print it. And then the scorpion's here. If I had stored our length, there's Cherry. So it's going through and it's saying, I got nothing, I got nothing, I got nothing. Oh, Jerry. Okay. Let's just write our functions here before we get started. Good to have them. Now, I was doodling the other day. And I drew a little character. I drew this little dog with little goofy eyes, and I like this dog. I've been like trying to get into this sort of hyper minimalist art style using like 1 or 2 colors. So I thought like I want to show you something cool. We've got our dog in Sprite 1. And I want to show you the map editor. Now we click over here and it looks a lot like the Sprite editor. Like these controls are, I think, identical. And then there's this space here, and you can see we're sort of selecting like on a grid here. And I can actually middle click or space bar and click to drag it around. And this is our map. And I can even mouse wheel to zoom out. And we can see the limits of the map here. And this is the map data that we get to play with. So I'll start at the upper left-hand corner. Zoom in all the way. And we can like click and drag. We've got a bunch of our little dogs. We can right click and oh, look at that. Look, it's selected that mysterious Sprite 0 that comes with the X in it. That is like transparency. That's nothing. So no matter what you draw in here on the map, it's basically transparent. And you can see we zoom out and zoom back in. So the way we can draw this map data, and if you want to see like more of the map, you can press Tab to get a slightly bigger view, or Shift Tab to get like a full screen. So we could get our corners of the screen here. All right. Let's see. So the way we can draw that, we'll get our CLS, and you can just do map and run that, and it draws our map. So what I want to do is make a little level for our dog. We'll see how the map screen works, what it's good for. We'll make a little game. So I'm gonna leave this row for my character, although I'm not gonna draw much, but we've got plenty of space. I'm gonna put like level stuff down here. And I think it'd be nice for the dog to have like a yard to play in. So let's draw like some greenery. Get some, this is a tight space to work in, but you can get some organic looking shapes in here. Now what I'm doing, I want to explain a little bit of like my methodology here, because I'm purposefully not taking up all 8x8. I'm leaving this border here, and I'll show you like it leaves a nice grid. And so if I just keep that clear, it becomes very obvious which grid tile you're on. So you can develop your own style, have fun drawing stuff, but this is just what I've been into lately. So we can make like a little level here. Maybe we want to keep the player on the screen. We want to make them feel like this level has bounds. And, I'm thinking ahead. I know I'm going to want some UI. I'm going to put it down at the bottom here, and I'm going to leave a little space for it. So like maybe the dog will start up here. I can put a little placeholder here, and like we can have a little room and like, a door, and like maybe there's like a hallway kind of thing. I'm thinking about this kind of like architecture, just gameplay reasons. But yeah, maybe the door is like over here to get up and you know, maybe like there's a goal up here and like little diversions along the way. The cool thing about this, we can have different tiles. So maybe we have like a brick texture, and I'll break my rule a little bit because it's nice that this can like tile evenly. And we can make this like a room. Like maybe one down here. And so we're getting like a kind of sense of space, a sense of place here. You know, maybe we can have like a... I'm trying to think of what other things are in like a yard. Have a little flower pot. Maybe we can put like a few flower pots around here. Let's get rid of the dog because we don't want the dog to be part of the map. The way I've been organizing code lately is I'll keep things in sort of modules, related code in their own tab. So we can say dog new, take in an X and a Y. And we will just return a table. And we can leave little notes to ourselves. For the sprite number, because I don't want to have to like remember what number everything's on. I've been calling it IM for image because sometimes I have like a speed variable and SP for sprite. You know, it gets confusing. So, and that's all we need for now. And we'll do function dog update. And I'm going to do something where we pass in the dog as D. And I'll sort of explain that in a second. Dog draw. Now there's gonna be a bunch of code in here to help us sort of navigate. Here's something I've been doing. Leave a little comment and then fill a line just with dashes. Just make a nice line. What's update dog? Not much. Okay. And we can do that in our like main. Cool. Here we can do dog equals dog new and give it an X and a Y. We want 2, 2 because if you see in the lower left-hand corner, there's like map coordinates. That's 2, 2. So I kind of got to talk about like pixel space versus map space. Because as we know, the Pico-8 screen is 128 by 128 pixels. And the map draws that many pixels. But it's like a data structure that is only 16 by 16. That's why it snaps like this to this grid. And each one of those grid cells just contains a number. And the number is what sprite is there. So I want to work in the map grid space, not like pixel space. So the dog's position is going to be 2, 2. We'll start there. We'll do dog update, pass in dog. And dog draw, pass in dog. Now, let's write this dog draw. So we're passing in the dog variable, and the argument is D. And so it's just like kind of a nice little shortcut. We don't have to write dog every time. We can just write D within that function. And then there are other benefits, like if we had multiple controllable players or something, like we could reuse the same update and draw more easily. It's kind of nice. So if we do sprite d.im for image, d.x, d.y, and we run this, our dog isn't where we want to be because it's at pixel space 2, 2. And we want it to be in map space, which just means we want to multiply this by 8. Great. So that way we can think of the dog's position in map space, and then it draws in pixel space. Now usually, I think before we've done like if button up d.y minus equals 1, and then keyboard shortcut to quickly duplicate a line, Control D. Really nice. We can do plus here, we can do X here, we can do plus here, we can do right, we can do left, we can do down, and pretty simple. Okay. Whoa. And we want button P. Yeah. Now we have this grid-based movement, very snappy. We could animate this, but then, you know, we'd be here all day because I've got other stuff I want to explain. Thing is, we can go wherever we want. Now, how do we limit the movement of the player? First of all, I want to do something. This is something I think is useful. Comes up a lot. I'm going to make a local called nx and y, two locals. Set them to 0. This is short for input y and input x. I am going to edit that instead of the position directly. So I'll do get input, update position is what we'll do at the end. d.x plus equals nx, d.y plus equals ny. Same exact code. One thing I kind of want to fix before we get to it, if I hit diagonals at the same time, we can get this diagonal movement. I want to prevent that. There's probably ways we could do that. I'm just going to do if ny is equal to 0, then wrap this in a then. And that way, like, if an up or down comes in, then we're just not going to ask for the left and right. It means it's going to prioritize up and down, but really it's just to prevent diagonal movement. So what we want to do, we take in the player input, and we update the position based on that input. And in between that, I want to check, are we going to hit a wall? So we want the target position, like the position that they are targeting. And we'll do local tx, ty equals d.x plus nx, d.y plus ny. And then we want to ask the map, what tile is there? Is there a wall there? And we can use this function mget. All that is it takes in an x and a y, it looks at the map data, and it tells you the sprite number that's in that position. So I can say local target equals mget tx ty. And we can say local wall equals target is equal to 16. So it will evaluate this logic. If mget returns the number 16, assigns it to target, if that's 16, then wall will be true. Otherwise, it'll be false. And then we can just say, if not wall, then we move. Great. Perfect, right? Except that not all of our walls are Sprite 16. That's a problem. Now we could like set this to false, and we could do if target is equal to 16, then wall equals true, and if target is equal to 17. And every time we wanted to add a piece of art that acted as a wall, we'd have to write more ifs. It's not ideal. Let me show you something. In the Sprite editor, have you noticed these buttons? You can toggle them on, toggle them off. Down at the bottom there, they say flag 0, 1, 2, all the way up to 7. So there's 8 of them. We can check if a sprite has a flag turned on. And this has a lot of uses. The classic use case that we're demonstrating now is it a wall? So we can just set flag 0 for everything we want to act as a wall. And then here under sprites, there is this function fget for flag get. And it takes in the sprite number and the flag you're looking for and returns true or false. So we can say wall fget target 0. We're looking for that 0 flag. And if the target that mget returned has the 0 flag, wall is true, and it will behave like a wall. Now we can add all the art we want. Just turn on that flag, slap it down, and it will be a wall. So our dog's got a yard to play in. What do dogs like? It'd be nice if our dog had some bones to pick up. Maybe like a bone in there. A bone in here. Now, how do we make it so that the dog like picks up the bone? Well, we can decide that like flag 1 is like our collectible flag. So we could say if fget target 1, we'll make a little comment. This is for collectibles. This is for walls. Then set txty 0. So we want to edit that map data. Make that square a blank tile. Great. Now, as far as like gameplay, we're not like tracking how many bones we've collected. So maybe up here we can do like bone equals 0. Make this our inventory. And right now we'll just do d.bone plus equals 1. And then like we probably want to draw that on the screen. Let's make a new tab for UI. The function UI draw, take in the dog. We'll just put in an X and a Y. 0, 121. And we will just print d.bone at X and Y, the color of 6. And down here, UI draw dog. Great. We could even do like Sprite 32 X Y minus 1. I think we just want to shift it up a smidge. And then we can just do X plus equals, I don't know, 9? And then we have like a little icon, a little bone icon, so we don't actually have to write the word bone. I kind of want like a doorway here, like maybe a door that you need a key to unlock. And I'm like, what is like thematically appropriate here? What would get in the way of a dog? So I think I'm gonna draw a cat. And we'll do 2 colors on our cat. We'll give him orange eyes. So like just a cat, just sort of like taking up space. Right. And then what would our key be? Maybe like something we can trade. Maybe something we can collect and trade to make the cat go away. Cats like fish. Boom. And we can mark that as collectible. We can mark the cat as a wall. We can sprinkle some fish here and there. Put a fish here. Put a fish here. You know, I'm not thinking deeply about puzzles at this point. But let's see if this works. Yeah. Okay, so we're collecting the fish, but it's counting it as a bone. Instead of being like, if target is equal to 32, then add it to bone. If it's 33, add it to fish, right? Which we should add fish to our inventory. I kind of just want to be able to say, like, look it up yourself. You should know this. So at the top here, let's make a table called obj for objects. And what we want, we basically want to be able to ask, like, what's the name of the object that the Sprite 32 belongs to. We can use that like array property of tables to ask it about a number. What's in this position? We could do like object 32 equals fish, set a string. The way you do that inside these brackets is you put your little straight brackets in here and you do 32 equals bone, .33 equals fish. So we check if it's collectible. We set that, clear that map tile. And then we want to get the name of that sprite, which we're storing here from the number, which corresponds to a named variable in our dog table. And so what we can do, we can get the name by doing obj object target because target is the sprite number. And this will give us the name. So we can do like local oname for object name. And then we can do d brackets oname plus equals 1. And if we wanted to be safe about it, we could do if d oname then do name plus equals 1. This is just like a safety thing. If we haven't previously defined this name in our inventory, this will return nil, and nil is evaluated as false, and so it won't try and add 1 to it. But if it finds it, if we did define it, then it will add 1. So it will look it up. So why are we doing this in brackets instead of d.oname? It's because this would be trying to access, like, literally, if we had a variable in here, oname. And so if we have a string and we're trying to access the variable whose name is the same as that string, this is the way we write it, with these brackets. Now we're going to need to do Sprite 33 for the fish. And we'll do our little trick here. Do 15. Sprite 33, x, y minus 1. X plus equals 9. Print d dot fish x, y. We need to do plus equals. Okay. Now, our fish and bones are separate. Now we need to add an interaction with the cat. So we'll do cat. If wall and obj target is equal to cat, I'm just going to put this on another line like that, then, so this is like if it's a wall, and then we look up in our obj table, check and make sure it's a cat, which we haven't defined, so we should define that. So the cat is number 19. Give it a fish if we've got one. So if d.fish is greater than 0, then d.fish minus equals 1, take away a fish, m set tx, ty, 0, just get rid of the cat. And we'll say wall equals false, just so we're not blocking the dog's way anymore. Let's try it. So we can't get through. Go pick up a bone. Can't get through. Pick up a fish. And the cat's gone. And we've made ourselves a little puzzle here because we went for the easy bone. Now we can't get through. So let's go down here first. Get this. Get that. Get that. Get that. And then, hey, we got all the bones. We got all the cats. What if we wanted to add a little more interactivity to this? If we wanted something we could push around. What's a video game without a crate, huh? Maybe we could scatter some crates around here. We could like make this a little hard to get to. We could say that in here. 20 equals crate. And these don't have to be in numerical order. I think we can just do what's convenient for us. We want the crate to be a wall. Maybe we'll do like a pushable flag. So flag 2 we'll say is pushable. Do crates or pushables. Pushable, just to push, equals fget target. Was it 2? Yeah. If push, then we've got the crates x and y, which is tx and ty, and we want the position where it is to be pushed. We'll say cx and cy. When you're making such short variable names, it gets hard to name because it's like, well, I've used that for center before. Well, it doesn't matter. Well, this will be like crate next position equals tx plus nx and ty plus ny. And we want to check that position we'll be pushing it to see if there's anything there. We just want to check if it's empty. So we'll do if mget cx cy is equal to 0, then we will mset the crate's current position to 0 and set its movement position to whatever it was, because just in case we want to have other pushable things that aren't crates. And then at that point, we want wall to be false, I think, so that like we're not bumping off of it awkwardly. I can show you. Here, let's make sure this works. Okay, yeah. So it's like I'm kicking the crate, which I want to push it. So yeah, it won't stop our movement. Now, if there's like 2 crates, we can't move it, which I kind of like. I think that's an interesting like gameplay mechanic, but like, yeah. So now we can sort of move things around. And we messed up here. And we can like kind of get ourselves locked. You know, we can mess up and we have to restart. This is starting to look like a puzzle game. Like if you, and look, the bones even stop the crate. You know, now I can push it. So like, you could have some fun designing a game with like just this toolbox, right? I kind of want to draw some more stuff. So like we could give our dog a dog house. Mark that as a wall. We could give our dog like a bowl. And if you want to adjust the sprite within itself, sort of, you can use the arrow keys to move it around where you want it. And a nice thing, like if it goes off, it'll loop around. So this is great for making patterns and things. But we'll just like keep it around there. Mark that as a wall, and then we can go back to our map screen and do a little decoration here. Yeah. Got this little dog adventure. I kind of want one more collectible. Maybe like the ultimate goal. Tennis ball. Tennis ball up there. And here, let's... All right. So she can get the tennis ball. We'll just kind of hack this. Local m equals d.m if d.ball is greater than 0, then here, we'll do like a one line. M equals 2, and then just be in. Test this. Right, we need to 34 is ball. Gotta make the ball a pickup. Boom. Now she's got the ball. Now I'm no great puzzle designer, but we've got like this tool set. Right. With this map tool, now that we've like built up this basic thing, we've got these interactions driven by our flags, we can pretty quickly just like throw down ideas and test them out and see like, okay, yeah, like there's a puzzle, you know, if I do this, oh, now I'm like soft locked. I do this, then I can get this, then I can go up here and get that. You know, if I can't get through here, but I can do that, and I can push that out of the way and get these fish, and I can push that out of the way, and then like make sure I don't get myself locked in, and then pay off this last cat. Used up all my fish. I got my ball. So have fun, play with the map editor. Maybe try setting flags, thinking of how you could use them with different interactions, or just use this, see if you can make something compelling. Where we could go from here, I mean, there's a lot more space for more levels. Could make a whole puzzle game in here. You know, we could have like a doorway that opens up here and like more world to explore. We would need to learn how to manipulate the camera or the game state, which we'll definitely talk about. But for today, I think that is a good chunk of learning. Have fun playing in the map editor. Have fun drawing sprites. Have fun designing puzzles. We're kind of getting to the point where you know a lot about how stuff technically works. And now it's just sort of learning techniques, how to use that knowledge to make things happen. And so I'm a little overwhelmed at the potentials for things to teach you, because you can already do so much. And you might not know it yet, but get excited. So that's all the time I have for today. I need to get back to playing Animal Crossing New Leaf on my Nintendo 3DS.